So, number 5, there is nothing here to distribute. If you don't see any parentheses, then there's no possibility that we have to distribute, right?
Yeah.
So we're going to jump right into our fraction busting. The first thing we need to do is figure out our LCD. The denominators that we have are 7 and 14. And 1, good point. We got to write a 1 underneath this 2 here. So our LCD, let's go ahead and make a quick LCD table. If we've got 7 and 14 times 1 times 2, 7, 14, 14, 28. Very clearly, our LCD is going to be 14, right? And a lot of you could tell without even making an LCD table. If you can recognize that one of the denominators, like 7, is a factor of the other denominator, 14, then the larger denominator is your LCD. This is very important because, what was I going to say? Basically, that's all you have to know for the test tomorrow. Whatever the larger number is, that's your LCD. So don't stress about finding the LCD. You'll see what I mean tomorrow. Anyway, we have to now find whole fractions that we can multiply each of these terms by to give us a 14 on the bottom. So, what are we going to have to multiply? Let me rewrite this just so it's a little bit neater. If we've got 4 over 7x plus 2 over 1x equals 2 over 14x minus 6 over 7. What can we multiply 4 over 7 by to get a 14 on the bottom? 2 over 2, exactly. Remember, whenever we multiply, we're multiplying by a whole fraction. We're multiplying by a whole fraction every time. What can we multiply 2 over 1 by if we want a 14 on the bottom? 14 over 14, right? That's the only thing we can multiply 1 by to give us a 14 on the bottom. What about 2 over 14x? We could say that we're multiplying it by 1 over 1. Really, it doesn't do anything, but just to be consistent. And then what about 6 over 2? Or I'm sorry, 6 over 7. What can we multiply that by? 2 over 2. That's right. This is going to give us 14s across all of our denominators. 2 times 4 is 8 over 14x plus 2 times 14 gives us 28 over 14x. Take a look and see if you actually wrote an x after that second term, because I know 75% of you did not, because I saw it yesterday. This was the biggest mistake that people consistently made, was forgetting that this is a variable term, 2x. Equals still 2 over 14x minus 12 over 14. 4 terms in total. All 4 terms have a denominator that is the same. So what can we do with that denominator?
Cancel them out.
Cancel them out. All the 14s go away, leaving us just with what's across the top, which is 8x plus 28x equals 2x minus 12. Again, you may have forgotten that 28 needs an x next to it. If you made that mistake, it changes everything that you're going to do from this point on. Because if we look back to our solving order, we're not going to jump right into inverse operations because we need to first combine like terms. What are the like terms here that we want to combine? 8x and 28x. Notice how they're on the same side of the equal sign. This is the reason why we split the equal sign down the middle, so we can clearly see, hey, there's 2 terms here that are alike on the same side. We've got to combine those first. The way we do that is we draw this little bubble around just the numbers. Kind of looks like sunglasses, remember? Just around the numbers, not including the variables. And then we add them together. 8 plus 28 gives us 36x equals 2x minus 12. What are we going to do next? We're going to bring our variable term over to the left and subtract 2x. I'm going to bring this over here. Now we've got 34x equals negative 12. Was it minus 2x gave us 34x, I believe, right? Yeah. 36 minus 2, yeah, 34. How? So 36, if you take 2 away from it, you get 34. And then the x just stays on the end for whoever asked how. Okay? Now what are we going to do? By what? 34, right? We want x to be all alone. We've got to divide by what's in front of x. Because 34 over 34 is 1. Negative 12 over 34. Can we simplify that at all?
Yes.
Yeah, what does it simplify to, Theo?
Negative 6 over 17.
Thank you. Negative 6 over 17. Just like I mentioned in our fraction lesson, you may get an ugly answer sometimes. That's okay. As long as you're confident in what you did step by step, be confident in your answer. But the important thing here is to remember that there's 2 variable terms on the left. A lot of people are going to make that mistake tomorrow. There is 2 variable terms here on the left. Now, I'm not saying that number 5 tomorrow is also going to have 2 variable terms on the left. It's not what I'm saying. I'm saying that we need to be very aware of what each of our terms is, or what type of term each of our terms are. One solution, no solutions, many solutions. What do you guys think?
One.
Definitely one solution. Whenever we see letter equals number, that's one solution. I saw some people yesterday get this ugly fraction, even though it's correct, it's still ugly. They got this answer and put no solution because they assumed, oh, if it's negative and it's a fraction, that must not be a good answer, so that's going to be no solution. Not the case, okay? Not the case. We'll know it's no solution if we see something like 2 equals 5. That's when we have no solution. We may have that on here. I don't think we do, actually. Oh, we do. Perfect. Number 8. We'll get to that. Any questions on 5? This is going to take up the most time because 5 has fractions, and that always takes up more time. But is there any questions I can answer about number 5 before we move forward? Okay. Taking a look over at 6. Is there anything to distribute here?
No.
No, there's not. Is there any fractions to bust here?
No.
No, there's not. Is there any like terms that we can combine on the same side? Well, we got to figure out what the 2 sides are first. There we go. That's nice. Now let's take a look at the left. We've got 10 plus 4x minus 3. What are the 2 like terms here on this side? Noah?
10 and negative 3.
10 and negative 3. We're going to circle those up. What is 10 minus 3? 7 plus 4x equals, now, can we combine any like terms on the right-hand side?
Yes.
We sure can. 5x minus 2x, we're only going to circle up the numbers so that we can see we're doing 5 minus 2, which is what? 5x minus 2x, folks? 3x plus 16. And again, this is the form that we want. We want there to be a constant and a variable on the left and a constant and a variable on the right. That tells us that we're going to start our inverse operations, moving terms over. What's the first term that we want to move here? Do we want to move the 7? Do we want to move the 16, the 3x? Yeah, we're going to move the 3x. We always want to start with our variable term. Looking back to our solving order. Inverse operations. The first one is add or subtract the variable terms to one side. So we take 3x. We do the opposite of 3x, which is negative 3x. And we do it to both sides. Giving us 7 plus what? 4x minus 3x. What does that leave us with? Just x. We could say 1x, but I'm just going to put x. And then we've got 16 on the right. clearly our last step here is going to be to do what? Typically our last step is divide, but what's our last step here? Subtract the 7. We don't need to divide here because x does not have a coefficient. 16 minus 7 gives us 9. One solution, no solution, many solutions. What do you guys think?
One solution.
There we go. Beautiful. One solution. Letter equals number. No matter what the number is, ugly or not, it's one solution. What if I were to get something like x equals 0? How many solutions would I have there? Would it be one, many, or none? What do you guys think? If I had x equals 0.
1.
That's right. That's going to be one solution. Even though 0 is a special number, it's still a number, right? Okay. Moving on down to number 7. Now, number 7 had a lot of people frazzled yesterday. And I think it's because we don't typically see equations that look like this. But again, we cannot expect any particular type of equation on the test. What we can expect is equations in general, right? We're preparing for this by adding in all these different elements to the process along the way. That's what we've been doing. That's why I keep saying we're building our toolkit, right? So we can't expect to see a certain thing, right? I can prepare as much as I possibly can to teach you guys the math for the day, but throughout the day there's going to be things that come up that I'm not prepared for, right? I have to figure out what to do based on all the things I know in my brain, in the same way that you guys will have to use all the things that you've learned this unit to solve a problem like this when you see it. Because what's actually the first step we're going to do here? And it's really the only step we need to do at all. Combine like terms. Exactly. Negative 5x is a variable term. 6x is also a variable term. So we can, and they're on the same side. Exactly, Azalea. They're both on the left. So if we combine negative 5 and positive 6, what do we get?
X equals 4.
Just x. 6x minus 5x, or negative 5x plus 6x just gives us 1x. So x is equal to 10. Super simple, right? Now, you don't have to self-report here, but did anybody subtract 6 over to the other side and then divide by negative 5? It's okay if you did. It's all right if you don't want to say you did. That's fine. But I know that some people made that mistake. That's okay, right? Dylan? Yeah, go ahead. That's okay if you made that mistake, because right now is the time that we're talking about the corrections to those mistakes, right? How are we on time? Oh, I got time. So, that's all for number 7. Pretty simple. Number 8. The first thing we are going to have to do here is going to be to do what? That's right. We take a look. Step 1 is going to be to distribute. We see parentheses. We know that we're going to distribute. So one of the things on the survey I gave you yesterday that people would like demonstrated again is how to actually distribute. So here's how we're going to do that. If you're one of the people that asked that yesterday, definitely make sure you're paying attention right now. The number that we are distributing is 3. We're going to distribute it to both terms in the parentheses. That's A and that's 3. Okay? In this specific instance, when we are distributing, we don't want to think of this as a negative 3. Okay? And we'll see why. We've talked about it before, but we'll see why. We just want to focus on the number when we're distributing. Left side stays the same. 6a minus 1 minus 3a equals. And now we have 3 times a. And we've got 3 times 3. Now, what sign do we want to go in between these two things? A minus sign, because that's the sign we have in between in our parentheses. This minus sign just comes right down. The reason why we don't want to include the negative on the 3 is because if we do that, you have to know that you need to put a plus sign in between them. Okay, that's just an extra thing for you to remember. It's not helpful. Just keep the numbers in the, when you're multiplying, just focus on the numbers. Bring the sign down and keep it the same. And then we just multiply. 3 times a is 3a. 3 times 3 is 9. Now we've got a nice clean right-hand side of our equation. Left side so far has not been touched. We move down our solving order and we see there's no fractions to bust, so it must be time to do what? Combine those like terms. What are our like terms on the left-hand side here? That's right, we've got an A and an A. We'll combine those terms. 6 minus 3 gives us 3A. So we get 3A minus 1 equals 3A minus 9. Now we're going to do our inverse operations. We want to focus on our variable term first. So what are we going to move?
3A.
We're going to move 3A over to the left by subtracting 3A. And what do we notice happens here when we do that? Noah?
You got 0.
All of the 3A's cancel out. Exactly. Now, if this 3A was alone on the left, we would write a 0 here. But it's not alone. We've got a negative 1. So we'll rewrite that. And on the right-hand side, we've got negative 9. Is there anything else we have in this equation at this point? No. That's just what it is. So, I'm confused. Does negative 1 equal negative 9? No, absolutely not. Those are two very different numbers, right? So is this going to be one solution, no solution, or many solutions? No solution at all. This is a false statement. If you think back to a couple weeks ago when we were doing something similar to this, that is a false statement, so there is no solution at all. Questions on number 8 that I can answer? Okay. Show of thumbs real quick. How are we feeling about this so far? Thumbs up if you're like, oh, my work checks out. I was doing it right. Thumbs sideways if you're like, okay, I got most of the stuff right, but I see the mistakes that I'm making. And then we're not going to do a thumbs down for this one. Okay. Good. That's a decent number of thumbs up. Couple more and then we'll be done. Taking a look at number 9. Number 9 is a little bit different because we have our constant term all alone on the left. Typically, we see our constant terms alone on the right. Doesn't change anything about the way we approach this problem. There's no distributing to do. There's no fractions to bust. So what can we do first? Combine like terms. Negative 10 doesn't have any like terms with it on that side, but what are the two like terms we have on the right? Negative 8y and positive 4y. They both have that variable with the same power. So we take negative 8 plus 4, and that gives us what? That's right, it gives us negative 4v. We've still got plus 6 there as well. Now, this is where things get a little bit different because technically, the way we learned how to do this, our next step would be to do what? Miguel?
Oh, I didn't drive it.
That's fine. The way that we learned it, what would our next step here naturally be?
Subtract 6 from both sides.
So good. That is what we're going to do. But remember, the first thing that we're told to do with our inverse operations is to move the variable term to one side. So you may look at this and instinctually go, oh, I have to add 4v to the left. But is there anything to combine 4v with on the left? No. So technically speaking, we've already met this first step. All of the variable terms are on one side of the equation. They're just on the right-hand side, which is not typically what we see, but it's still true. All the variable terms are on the right. So instead of moving 4v, we're just going to move 6 over to the left so we can combine it with negative 10 and get negative 16. Now we see, even though it's flipped around from what we normally see, we can see that we're going to divide both sides by negative 4 and get v is equal to 4. The negatives cancel out. 16 over 4 gives us 4. Is that one solution, many solutions, or no solutions? What do you guys think? One solution. Exactly. Thank you. Questions on number 9? The variable's wrong? Oh, it's a y? My bad. All right, over to number 10. What's the first thing we want to do here? We're going to distribute, right? We're going to distribute negative 8 to w and to positive 2. Now, we're going to be really careful here because we're distributing a negative number. Whenever we are distributing a negative number, we have to be super, super careful of what our signs are when we multiply, right? First, we have negative 8 times w. Then we have negative 8 times 2. What sign is going to go in between these two things? A plus sign. We take the sign that's in the middle and we bring it right down. Negative 8 times w just gives us negative 8w. But negative 8 times 2 gives us what? Negative 16, right? Now, I have a plus sign directly next to a minus sign. Whenever we see that, what are we going to turn that sign into? A plus next to a minus sign turns into a minus sign. Exactly. If we are adding a negative 16, that's just like subtracting 16. Let's go ahead and combine our like terms here as well. We've got negative 8 plus 2. That gives us negative 6w minus 16 equals 22. And then what do we do to both sides? We're going to add 16. Thank you, Hannah. We're going to add 16 to both sides. Those go away. Negative 6w equals 38. I think it is, right?
I believe so.
Yeah, 38. I'm going to bring it up here. Negative 6w equals 38. Last step is going to be to do what? Divide both sides by negative 6. We're left with w equals negative 38 over 6. Can we simplify that at all?
Yes.
We sure can. What does that simplify to be?
19 over. Ow.
Negative 19 over 3. Great job. One solution, no solution, many solutions.
One solution.
One solution, exactly.
One solution.
Remember, most of the time you're going to get one solution. Very rarely will you see no or many. But it's important to be able to point that out when we do see it. Right? Speaking of pointing things out that we see, let's take a look at number 11. Now, I'm not sure if I mentioned this yesterday, but on the test tomorrow, number 11 will be extra credit. Okay? You will not have to do number 11, but it's recommended that you at least try number 11 because it can't hurt you if you get it wrong, but it also can't help you if you don't try. Adoria, what's up? Okay, my bad. So, even though it's extra credit, we're still going to talk about it. What is Amelia's error here? What did she do wrong? Can someone help me out? Azalea, help me out. What did Amelia do wrong here?
She fraction bust wrong.
Okay, how did she do the fraction busting wrong?
She looked at the denominators 3 and 4, and she supposed that the lowest common denominator is 12.
Perfect.
So she multiplied 1/3 and 3 over 4x, 1/3 x and 3 over 4x by 12, but she didn't multiply it by -4 and 1.
Exactly. So this person did the fraction busting a little bit different than how we learned how to do fraction busting, right? We learned we multiply the terms by the whole fraction that gives you your LCD on the bottom. She did it the other way, where you just multiply all the terms by the LCD and then cancel out whatever you can to get 4 and 9 here. But notice how we didn't multiply -4 by 12, and we didn't multiply +1 by 12, right? Even though they're not fractions, we still have to fraction bust those terms. Every single term in the equation needs to have the same denominator. All right? Does anyone have the correct answer to this equation? Azalea, what did you get for the correct answer to that equation?
I got
-12. Did anybody else get -12? Give me a thumbs up if you got -12 here for number 11. Anybody? Very nice. Good, good, good. I'm not going to write all that out because it's extra credit. So if you remember it, great. It'll be a different problem, obviously, but be sure to look for the errors. Every term needs to be fraction busted, even if it's not a fraction, right? All right. Final questions about anything revolving around